Hello, today I'm going to talk about the BJT, bipolar junction transistor. It means the bi means two, so the BJT drive the current on by holes and electrons of two kinds. So it is different from MOSFET. MOSFET is unipolar transistor. And the junction means the PN junction. So BJT can be type of PNP or the NPN of two kinds. So we can see the structure of BJT like this: the emitter and base and collector. We usually say BJT type is the NPN is NPN. We can say the emitter is similarly to MOSFET's source, and the base is like MOSFET's channel, and also the collector is drain. So we can see BJT easily, and on this structure we can think about the Kirchhoff current law and the voltage law. So VCE is equal to VCB plus VBE. This voltage means the between voltage of the emitter and base is VBE, and also the VCB is between the collector and base voltage, so on. So this Kirchhoff, the voltage law we can see, and the current law we can see the emitter current IE is equal to IC plus IB. The IE is the emitter current, and it is equal to IB plus IC. This is because the emitter is the sourcing part, so we can see the emitter current is the biggest current, and we can also see the common base gain. This common mean the grounding something, so the base is makes ground, and we can see the relationship between the collector and emitter's currents. So and we say the IE is equal to IC plus IB, but the base current is very small, so IC, the collector current, is almost equal to emitter current, but emitter current is little bit bigger. So this almost we can say the 0.99, or ideally we can say it is 1. Also the common emitter gain, this is emitter makes ground, and the we can see the relationship between the base and collector. It is almost 100. Okay. Lastly, when the NPN BJT, the band diagram looks like this. and when the emitter base collectors on between BE and BC for forward and reverse bias, we can see the when the forward it is the voltage saturation, and for the reverse is forward active. Opposite is reverse active, and reverse we can see this part is cut off. To explain the one part of cutoff, when the emission and base get reverse bias, the reverse bias is the N have the plus bias and P have minus bias, so the bases band go higher, so the emitter and go down, so this potential barrier is go larger, and also the this base and collector part, the plus and minus the base also go up and collector go down, so we cannot see the current flow, so it is cut off part. And the example of the forward active, the BE forward, the forward bias is the P type positive bias and N type the minus bias, so the potential barrier go lower, so the electron can go through base. And also the reverse bias of the BC, the base and collector, so it makes the on MOSFET we can see the current flowing by the source, and the channels the barrier height is lower, and the source and drains the potential difference makes the current flow, so it is similar to this part. So the emitter and base potential barrier is lower, and the emitter and collector's potential barrier has difference. We can see the current flowing. Okay, thank you for listening.